So hello everyone, my name is Andrea and I'm going to talk about Mobx State Tree, actually a very brief introduction about it. Before I start, I just want to let you know that I have this nasty cold and I might start sneezing. So a little bit about me. I'm a software engineer contractor at Dazn for about a little bit more than a year. Besides that, I'm accessibility enthusiast and very much interested to motivate women to do more coding. So because Marian already said things about Dazn, I will not spend my time in here. So what I'm going to talk about today, I want to introduce you the Mobx State Tree and to explain you what it is actually. But before that, very shortly, I will have to talk about two concepts. It's a reactive programming and what is state management and how we are doing it with the Mobx. So, reactive programming, there are many definitions. The best I found on the web, and I think is mostly used at, what does it mean? It's a programming, programming when we use data streams asynchronously. So, sorry. So, I was talking about what reactive programming is. It is very often going hand in hand with functional programming also, but I'm not going to touch that part today. So if you look into this graphic or visualization, you will see a timeline, right? So we have this timeline, and then we have some these circles on it. So these are actually the stream of stream of data or events, or everything can be can create a stream, right? Imagine, for example, we are trying to capture click events. So you would see the click event over the time that user made. So whenever this, so let's say we are capturing the click events, and whenever that event would happen, the stream would emit a value, and then we capture that value asynchronously by a specific function. So we are defining these functions, and these functions we are calling observers. The observers are subscribed to those streams. So the stream, in this case, then we are starting to call like an observable or a subject, and it's being observed by that observer. So it is very similar to an observer pattern, and these are really the basics of the reactive programming. Of course, there are many more things, but it's not the topic today. So this was one concept I wanted to introduce, and the second is what is state management. So many of you, I guess many of you using Redux for the state management, right? Is there anyone who would use Mobx besides Dazn? No. So then I'll try to explain what Mobx is. So we have to have some kind of solution for the state management when we are working with the UI, and there are different solutions in the world. So most popular currently is Redux. However, Mobx is very interesting one. Why? Because it is non-opinionated on a way how we are going to structure our state container, meaning that it is not opinionated about, as Redux is, that you have to have a normalized data or I actually going to compare later a little bit more with Redux. It is having 4 concepts. So, of course, the application state itself, that is our model of the application. So it can be any data structure. From this model, we can produce derivations. These are computed values that are derived from the state. So if we can compute anything, for example, we have an array in our model, and then we want to filter and to take some filtered value from there. So from this, in this derivation, we can do it. So actions can change the state on a way that we never changing derivation, but we are actually with the function we modify the state model that will actually produce a change in derivations. And the fourth concept is that we are having reactions. As derivations producing a value, reactions are not producing value, but they are very often they are usually performing a task. So for us, it's most interesting the DOM updates. Graphically, it looks like this. So it's very simple, I think. So as you see, when we have a state model, and for example, we have an action, we modify or mutate our state, the update goes automatically into derivations and into reactions. So our components would update on a state change. Very soon it's going to be much clearer. So because Mobx itself, it's not defining our data structure, and it is having really this open architecture. On top of it, some very smart programmers, I don't remember names, sorry, built the Mobx State Tree that is actually opinionated. What does it mean, opinionated state management? That you have to follow certain way of how to manage your state in this case. So it uses, very important is that it uses observable data, and the data is stored in the so-called trees that are, you see, mutable / immutable. It's very interesting. So you can mutate your trees in your stores, and you can freely work with the model. However, for every change, the same a snapshot would be created, and this tree would be kept as a serialized object. We'll come back to this. To remember that H3 has a state, that is actually our data, and the shape, that is a type information. So this is also very interesting that we have type information. So example. First of all, we import the types for a namespace from Mobx State Tree dependency, and then we're creating a variable that is adding the types model. So this is a very, very basic structure of the Mobx State Tree. So we name it book, and our model is having some properties. These properties are actually our state. However, these types are creating the shape of our Mobx State Tree. Meaning that if we define the title to be string, right? So we can, it would produce an error if it would, in runtime, if it would receive a number, for example. So this is a very base structure. So we have created another variable, and again added the types model. However, in this case, the books property using types array, but it is referencing to this book, right? So meaning that every item in the array has to have this structure. And then the create is creating the store itself. It can accept two parameters. About the second one I will talk later. The first parameter is the default value. So Mobx State Tree, it's a store. It's I mean, in Redux you're also using store, right? So try to reference it as a store. So I was talking about the model that is having this mutable state and types that define the shape. However, it is using two more concepts inside the store object. We have views and actions. If you remember the derived states from Mobx, we are calling here views. And these are the computed values. And also we are using actions, and with the actions we can update the store model. Example. We have a model. Here are the views, here are the actions. So views are accepting self as views are accepting, function views is accepting another function, right, that is having a parameter self, and we can use two types of functions inside the views to derive or compute another values. We can use getter, JavaScript getter, right? And then we can use a view function that so the getter cannot accept any parameter. The view function can accept parameters. That is the main difference. Mobx will update. I'm going to show later how in the component itself. So actions, the second item, actions. So with actions we are changing the state, right? We have an example of the action. For example, add to do parameter, what to do. So I'm pushing into this to do array. So I guess everything is very, very much abstract so far. How we are connect this with React. It is important to remember now that in this case, our React component will be really a pure view without business logic, without any business logic. So what we are going to want to do is just render the UI with it, and not to. So everything is our store. Three things we have to remember. To connect the Mobx State Tree to React application, we have to provide a wrapper around our root component and injecting the stores, our Mobx State stores. Very important to remember that unlike Redux, we can have multiple stores. We can have any number of stores we want. Two more things. So inside the component, we have observer, decorator, and inject decorator. Using the observer decorator, we are creating our React component. Actually, our React component become an observer, and it will listen to the change in the store, and it will react accordingly as in the store the changes would happen. With inject decorator, we are connecting the store with the component itself. So as I said, we can use multiple stores, we can inject multiple stores. So for different components, I can inject different stores into my component. I'm going to show you this soon. Here is how it looks on the root level. We importing the provider, right, and we are wrapping our app, so it is a root component, and injecting some example store here, so it can be more than one. In our React component, finally something looking familiar. This is important for us, so we are importing from Mobx React dependency, inject and observer. Are you familiar what decorator means? Okay. So decorators, you see this, is, let me try to explain. I would say it is actually not ES6 syntax, but higher, I think ES7. And it is actually used for instead of higher order, instead of wrapping a component into higher order functions. So it is kind of nicer syntax, you know, that it would add additional functionality to my component, but not changing the basic functionality. So with inject, we are injecting, for example, here a to-do store. Meaning that, and also we are adding the observer decorator, meaning that our to-do component will become, will look for the changes in this store, okay? So, automatically, as we added this inject, our components will receive props from this store, and the store itself becoming the props of the component. If I destructure the to-do store, you will see that I have access to my model properties, right? Then I have access to the views and also to the actions. In a component itself, what we can do now, so what we can do, we can print the state, right, the current state, the model out. We can create a new button and, for example, add a new to do to our store, meaning that we would use these props and then create an action that would create a reaction, right, and then our store would again update. Everything's happening in Mobx State Tree, nothing in the component. As I mentioned earlier, that we can have as many stores as we wish. So it can create some kind of chaos, I guess, and we can shape those stores on different ways. One of the two most popular is then we have one root store, or we have multiple parallel stores. This is one of the examples. So these are our React components here. We have our stores that are all actually imported by the root, and then we are injecting all into the provider only the root store. And the second example is that we're injecting into provider H store separately. So you might ask, okay, if we have these parallel separate stores, how they are communicate? Sometimes we have to communicate with the data, right, if they are separate. So there is something that during the creation of the store itself we can do. So we can actually inject another store into our original store. So we have created a bookstore here, and we have another publisher store, for example. And I want to use some data from in my bookstore, so from this publisher. In that case, during the creation of my bookstore, the second parameter will be the dependency injection of other store, and this is how I can access the data from here. And we are getting to the end. I hope that it seems like I was too quick. I hope that you have questions. Thank you.
You mentioned at a certain point that you could have multiple stores.
Yes.
And I was just curious, what was the reason why they felt they needed multiple stores? Like, what is the problem that they are solving by having multiple stores? Is it separation of concern?
It can be, yes.
So, are there any other reasons why they felt the need to have that ability?
It can be. So it's not going to, your store is not going to be so tightly coupled, for example. So you can reuse some parts, maybe for other things. for example. This is where I'm seeing a surplus. Having one store is making sense when so I mentioned that as we mutate the data, right? So we are creating these snapshots that are kept as serialized objects. So we can time travel through our application. So having one store, actually having a root store and substores, makes sense, I think, if you need a snapshot of the whole application from some reason. But I think it's also possible just to send from separate stores the state what we need right now. So.
Which brings me to the next question,
yeah.
Especially if you don't mind. So I am curious, how do you use these multiple stores? Do you use them per page? And so when you need to communicate between those stores, how do you do that?
So as I mentioned here, so you have the React component. So it's not per page, it's per component.
Oh, per component.
Yes,
okay.
so you can use it per component. You inject the store itself into your component, and then if you use multiple stores, this store will have a concern only about this component, for example. I mean, of course you can reuse stores,
yeah.
but you can have unique stores per component. And what was you asked something else, I think.
Yeah, I was curious if you need data from 2 stores, how would you do it?
So that was my last slide, yes. I guess it wasn't very clear. So during the creation of your store, you can inject another store into it. And then you have a specific namespace that I think it's called getEnv, where you access that store's properties.
Okay, thank you.
Welcome. Yes?
So when would you choose to use Mobx over something
I'm sorry?
else? When would you choose to use Mobx over something else? Or like, what are the benefits of it?
When would you use Mobx instead of something else, instead of Redux? Or?
Yeah.
Since I learned Mobx, always I would use Mobx instead of Redux, to be honest. But I think it's a matter of personal opinion, maybe. I don't see any specific business case when to use Mobx or Redux or something else. I'm not sure if my colleagues would agree.
We could chat later on that one.
And the performance, do you know, like compare?
I don't have numbers, but what I was reading is performing much better than Redux. Definitely. And we are really, my team is really developing an application that has to be high performing, and we are really satisfied. It's okay.
So it might be another question you don't know, because it's quite a sort of esoteric question. So I've had problems before where we had to roll our own state management library because nothing can handle recursive structures. Do you know whether Mobx can handle recursive structures or not?
Which kind of structure, sorry?
Can Mobx handle recursive structures?
Recursive, yes,
So when
definitely.
you can't trust the data to not refer back to itself at some point?
Like cycling.
Yeah,
Okay.
cycle structures.
The data in the Mobx State Tree is as a tree. If you would like to use different data types or data architecture, you can use just Mobx, right? So, and you can create your architecture. I'm not sure if I answered your question. I'm not hearing well because of my cold, sorry.
It's probably me. Basically, is Mobx able, how does Mobx store the data underneath, and does it account for complicated structures?
Okay, so we have the types, right? So under the model you have a properties, and each property can have type. What I've shown here, I didn't mention this because it was supposed to be just like introduction to the Mobx State Tree. So these types can be primitive types like string, number, boolean, and so on. Can be complex types. arrays, references, and utility types, if I remember well. I have to check all the types. There are plenty of types, so you can refer to any type, kind of data.
Okay. And in terms of types, where are they used? In terms of types, so like defining something as a string, is that used?
So this is your application state, right? So we don't want to mess with the types of our properties. So during runtime, actually, Mobx State Tree is checking the types that have been defined under the model, and during the runtime, it will throw an error if, for example, my title will receive some other type than string.
Okay.
Or it can receive a function, for example, so you have a bug in the code. So
is there a way, so the same as with flow type, to
like prop types?
At compile time? Yeah. So are there ways to use that at compile time as well?
Like?
Are there ways to use those types at compile time as well, either with TypeScript or with Flow?
Well, it's similar, I guess.
Yeah.
Yes.
Okay. Cool.